Good day everyone. Today we're going to solve problems in chapter 6, fluid flow measurement. So, determine the actual discharge in liters per second via a 200 mm diameter orifice with a 6.5 meter head and assume that CV is 0.89 and CC is 0.57. So first, we will proceed to our given. So our diameter is equal to 200 millimeter. So let's convert this into meters. So 200 millimeter divided by 1000. So we will have a value of 0.2 meters of our diameter. And our head is equal to 6.5 meters. And our CV and CC is also given, which is our CV is 0.89 and our CC is 0.57. And now we are looking for the value of our actual discharge. So let's proceed to our solution. So our main value of this is Q is equal to area times the velocity. So we all know that we didn't know the theoretical velocity in this problem. So let's find first the theoretical velocity. So we will have a formula of qt is equals to at times the velocity t. So we will get it immediately, the area, by using the area of the circle because that is the given. So we will have a pi over 4 times d squared times the velocity. Now the velocity we will use by multiplying the square root of 2gh. So by substituting all the givens from this equation, we will have a pi over 4 times the diameter, which is 0.2 squared, times the square root of 2 times our g, which is 9.81 meters per second squared, times the head, which is 6.5 meters. So by direct substitution, we will have a value of theoretical or our qt, which is 0.35 cubic meter over seconds. So now to get the actual discharge, we will have a formula of Q is equal to C, or the discharge coefficient, multiplied by the theoretical discharge. So to get that, we have to consider the qt, which is already solved, and also the discharge coefficient. So the formula of discharge coefficient is equal to cc times cv. So why we will use this? It is because that there is a relationship between coefficient of discharge, coefficient of contraction, and coefficient of velocity. So now, the product of coefficient of contraction and coefficient of velocity, that is the coefficient of discharge. So to get that, let's substitute all the givens that we have from the formula. So we will have a QA is equal to our CC, which is 0.57, times our CV, which is 0.89, and our theoretical discharge, our theoretical velocity, which is 0.35. So we will have a value of, if we calculate this, we will have a value of 0.18 cubic meter over second. So we are looking for the answer having a unit of liters per seconds, right? So let's convert cubic meter over seconds to liter per second. So by multiplying 1000 liters over 1 cubic meter, so 0.18 cubic meter over S times 1000 liters over 1 cubic meter. So if we calculate this, we will have a value of 180, and this unit will cancel out and we will have a remaining unit of liters per second. So our actual discharge is equivalent to 180 liters per seconds. So this is our actual discharge, 180 liters per seconds.